Congratulations. I rejoice with everyone on the start of a new year, year 2021. 2020 was a very harsh but remarkable year. With you all our partners in growth, we triumph over the hurdles that later all our paths. On behalf of the board, I say thank you to all our stakeholders that help us in attaining new heights. I particularly appreciate the Governor of Lagos State, Mr. Babajide Olusola Sanwo-Olu, a passionate, committed, and transformational leader. Thank you for the giant leaps we made, especially through Eco-Excel initiative. I equally thank our amiable and pleasant Deputy Governor, Dr. Obafemi Kadri Hamzat, for his immense support for all the activities of the board. I thank the Honorable Commissioner of Education, Mrs. Folashade Adefisayo, for her remarkable leadership role in the sector. To the Executive Secretary, Dr. Hamid Boboyi, and management staff of UBEC, ministries, departments, and agencies in the state that partner with us to ensure the smooth running of the basic education sector, I say thank you. To our corporate friends who stood by us and the people of Lagos State despite the harsh economic realities, I express our heartfelt gratitude. I'm particularly pleased with all our private sector partners in the recently launched Project Zero initiative. I cannot forget our wonderful teachers and parents who ensure that our children continue to learn even when our schools were shut. My sincere appreciation to the entire management and staff of LASUBEB and the education family for their hard work and commitment all year round. Let us get back to work with a renewed energy. Together we can achieve more. I wish everyone a happy, healthy, and prosperous 2021. Ìgbéga ìpínlẹ̀ Èkó, àjùmọ̀ṣe ni o.
Hello pupils, you're welcome to another wonderful edition of your favorite program, The Classroom in Your Home, a program organized by the Lagos State Government and packaged by the Lagos State Universal Basic Education Board, LASUBEB, to ensure that you are academically engaged in addition to what you're learning in school. I am Auntie Fumi, your English Studies teacher, and as usual, I have with me your wonderful teachers.
Hello children, I am your mathematics teacher, Uncle Agbaje, but you know me as the mathematician.
Uncle Popo is here, your general studies teacher.
And we also have our sign language interpreter, Uncle Wale, in the house. Together, we are bringing the classroom into your home. Please stay tuned. Pupils, you're welcome to Auntie Fumi's class. In our English Studies lesson today, we'll be looking at using for, since, and ago in expressing time. The topic again is using for, since, and ago when expressing time. Before we go into the learning objective for today's lesson, let's have the correction to our previous homework. You were asked to write the past and past perfect tenses of the following words in a tabular form. Did you do your homework? I trust you. Yes, I saw yours. Yes. Well done. You were asked to write the past and past perfect tenses of write, choose, sting, hit, and strike. So, the past tense of write is what? Well done. It's wrote. And the past perfect tense is written. Did you get that? Please mark. Choose. The past tense of choose is chose. Yes, chose. And the past perfect tense is chosen. The third one, sting. S-T-I-N-G. Sting. The past tense of sting is stung, and the past perfect tense remains stung. You have sting, stung, stung. The next one is heat. H-I-T. Heat. The past tense of heat is heat, and the past perfect tense of heat remains heat. Don't forget we told you that there are some words whose past tense and past perfect tense form do not change. Heat is one of those words. Lastly, strike. Strike. The past tense of strike is struck, and the past perfect tense of strike is stricken. Did you get the 5 correctly? Then you deserve to be celebrated with a cheer. Good job, you. Well done. Now to our learning objective for today. Don't forget I said today we are going to look at the use of for, since, and ago when expressing time. So, by the end of today's lesson, you should be able to state when to use the word for, since, and ago. You should be able to state when to use for, since, and ago. Not only that, you should also be able to use the word for, since, and ago correctly. Are we ready for today's lesson? Okay, you have your writing materials ready with you. I trust you. So let's go into the lesson. For, F-O-R, for. In English, we use the preposition for to talk about an amount of time or space. Don't forget that for is a preposition, and we use it to talk when we're talking about an amount of time or space. The amount of time could be seconds, minutes, hours, days, months, or even years. The amount of time does not need to be exact. It does not need to be what? It does not need to be exact. You could use the word for when you're talking about a vague period of time. When I say a vague period of time, I'm talking about a time that is not exact. For example, for the weekend, for ages, for a long time. That is talking about a period of time, a vague period of time. In English, the basic formula for using the word for is this. If you want to use the word for, this is the basic formula. We are not in the mathematics class, but yet this as a formula. For, you add a period of time to it. That is for plus a period of time. That is the basic formula for using the word F-O-R, for. The basic formula is for plus a period of time. Are we together? For can be used when talking about the past, the present, or the future. You can use for when you're talking about the past, the present, or the future. Here are 3 examples. You know, Auntie Fumi will always give you examples. So here are 3 examples of sentences that use similar vocabulary but use different verb tenses. I am giving you example of sentences that use similar vocabulary but different verb tenses. And the past tense form. Last year, I traveled for 3 weeks. Don't forget the formula for using for is for plus a period of time. What is the period of time here? 3 weeks. Last year, past tense. Last year, I traveled for 3 weeks. In the present continuous form now, I am traveling for 3 weeks. I am traveling for 3 weeks. Future tense now. Next year, I will travel for 3 weeks. Let's look at the examples together again. In the past tense, last year, I traveled for 3 weeks. Present continuous tense, I am traveling for 3 weeks. And the future tense, next year, I will travel for 3 weeks. Regardless of the verb tense, the preposition for is still followed by a period of time. That is to tell you that the formula remains constant when you want to use for in expressing time. For plus a period of time. Are we together? Good job, you. Brilliant children. Now let's look at the word since. S-I-N-C-E. Since. In English, we use since to refer to a point of time. We use since to refer to a point of time. The word since can refer to a point after a specific time or event in the past. That is, events that happened in the past. It can also refer to a particular point beginning sometimes in the past and continuing until the present time. Did you get that? We use since when referring to a point after a specific time or event in the past. And we can also use it when referring to a particular point beginning sometime in the past and continuing until the present time. The particular point in time could be anything. It could be last Tuesday, 2008, midnight, and so on and so forth. Are you with me? The important point is that since is used with a particular point in time. Since is used with a particular point in time. So let's talk about the basic formula for using since. Are you with me? Good. So in using since, the basic formula is since plus a particular point in time. You remember the basic formula for using for. For plus a period of time, and since plus a particular point in time. That is the formula. Please note that. In sentences with since, we usually use perfect tenses. In sentences with since, we usually use perfect tenses. When using since, we use present perfect and past perfect tenses in the main clause of the sentence. Don't forget the main clause. We've talked about that before now. So when you are using since, you use present perfect and past perfect tenses in the main clause of the sentence. You wouldn't use since when you are talking about the future because, by definition, since refers to specific points in the past. So you cannot use since for a future, for a sentence in the future, because since refers to specific points in the past. Here are 2 examples in the present perfect tense. It has been raining since 8 a.m. It has been raining when? Since 8 a.m. I have been walking since 10 p.m. I have been walking since 10 p.m. in the night. I have been walking since 10 p.m. And it means I am still walking. I'm still walking. So it started sometimes in the past and it's still continuing. So I have been walking since 10 p.m. We've talked about for and since. Now let's look at ago, ago. Ago. Ago is used when talking about something in the past that is considered in relation to the present. You are talking about something in the past and that thing is considered in relation to the present. It is used with the past tense and always includes an expression of time. Yes, it includes an expression of time. Minutes, it could be hours, it could be months, and so on. So when you say, I received my certificate 2 months ago, it would mean that it has been 2 months since you received your certificate. Should I take that again? When you say, I received my certificate 2 months ago, it would mean that it has been 2 months since you received your certificate. Are we together? Now it's activity time. In our English studies lesson today, we looked at the use of for, since, and ago in expressing time. And we had basic formulas for using for and since and even ago. So it's activity time. Are you ready to test how attentive you have been in the course of the lesson? Then let's see. Complete each sentence by filling the gap with for, since, and ago. I'm giving you the next 20 seconds to write just the answer. And your time starts now. Pens down, eyes on me. By now you should have supplied 5 answers. 5 answers, yes. So let's see how correct you are. Auntie Fumi got 5 out of 5. What about you? Are you sure? Then you deserve to be celebrated with a cheer. Good job, you. Well done. I am proud of you. Now your assignment. Your assignment, yes. For every assignment duly submitted, there is a prize to be won. You know that? So, here is your assignment. You are to complete each sentence by filling the gaps with for, since, and ago. 30 seconds for you to capture the assignment. And I'll come back to sign out. Now you've copied your assignment. Make sure you do your assignment and you submit promptly. And that's it for today. We have come to the end of the English Studies lesson for today. It was a fun-filled day with your children. Well done. It is time for me to hand you over to the mathematician for another beautifully packaged mathematics lesson. But don't forget, before I go, I will always tell you, Auntie Fumi is always proud of you. Bye.
Hello, children. You are welcome to this segment of the program, The Classroom in Your Home. It is mathematics time, and that means it is time to have some fun. I am Uncle Agbaje. Today is Monday, and just as we are able to exercise our body on Mondays, we exercise our mental muscles with the Mondays Math-a-thon. Are you ready for today's Math-a-thon? Well, you know all you have to do is to get your pen and your notebook and see how many questions you can attempt in 1 minute. Today's Math-a-thon coming right up. Begin. Alrighty then. How many were you able to attempt? You did all. Well, let's see how many you were able to get correctly, my friend. 45 plus 16 is 61. Did you get that? 13 plus 18 is 31. And you have 73, 100, 66. Tick along as I call the numbers 16, 45, 32, 36, 64, 42, and 42. If you got all, then you are a star in the making, my friend. But if not, I wish you better luck next time. Now on to the focus of today's lesson. Today we will be looking at perimeter of circles. I want you to imagine that in your brain. We have been taught what perimeter is all about, and we have done perimeter of regular shapes. And so today we will be looking at how to calculate the perimeter of circles. But before we go into that, the correction to the previous assignment, as is our usual practice. In the last lesson, you were asked to convert all these, change 12.5 kilometer squares to hectares, change 350,000 square meters to hectares, and finally change 685 hectares to square kilometers. Well, if I were you, my friend, I would keep that table of conversion right beside me as I walk, because that is the key to unlocking the door. Now, from that table, we can see that we'll be converting kilometer squares to hectares. The relationship between kilometer squares and hectares is 1 kilometer square is 100 hectares, and that is the relationship. So if I want to change 12.5 kilometer squares, I will just multiply this by 12.5, and I will multiply the other side by 12.5. And so multiplying 12.5 by 100, remember you have to move the decimal point twice, you will get 1,250 hectares. I'm sure you did this. I wouldn't want to spend too much time on that because you are smart and you have been taught how to multiply decimal numbers with powers of 10. Let's see the second one. So the second one says that we should change 350,000 square meters to hectares. Now the relationship is that 1 hectare is 10,000 square meters, or 10,000 square meters is 1 hectare. So if we want to change 350,000 square meters to hectares, we will only increase this 1 hectare in the same ratio, and that is putting the bigger number on top and the smaller number below. That is 350,000 over 10,000, then multiplied by 1 hectare. Now, if we cross out all the zeros, let me select a white pen. Now, we have 4 zeros here, 1, 2, 3, 4, and we have 4 zeros here, 1, 2, 3, 4. Then we are left with 35 over 1, and finally, that will be 35 times 1 hectare, which of course is 35 hectares. Now, did you get all, my friend? 1 over 2, 2, 2. Well, whichever one it is, you have done well, and I will celebrate you with a chair. Now, moving on to today's learning objectives. What are we going to be able to do by the end of the lesson? By the end of the lesson, you should be able to recall and name some parts of a circle. You should be able to appreciate the concept of pi in mathematics. It's not the same thing as the meat pie that you buy at the restaurant. Okay, so you should know what pi is in mathematics and appreciate what it means. And finally, you should be able to, of course, do the main work for the day, which is to calculate the perimeter of given circles when you know the pi and you know the diameter. Without wasting much time, let's just move right into it. Now, this is a circle. We have been taught some circle parts, but just in case you have forgotten, remember that the line from A to B passes through the center, and we call that line the diameter. The diameter is a straight line that divides a circle into 2 equal parts. It goes through the center. The line OC is the radius of the circle. This line from the middle O to C is the radius. And remember that the radius is any straight line from the center of the circle to any point on the body or the circumference of the circle. And finally, the total distance around the circle is called the circumference of the circle. That means if we start from C and we go around along the edges of the circle back to C, that total distance is called the circumference. All right, so keep that at the back of your mind as we progress in today's lesson. Now, the circumference of the circle, as we have described it, is actually the same as the perimeter of the circle. Remember that the circumference is the total distance around the circle. The perimeter of any shape at the same time is picking a starting point and going around the shape. So whether you are asked to find the circumference of the circle or the perimeter of the circle, my friend, both of them are one and the same thing. So keep that at the back of your mind. The circumference of the circle is also the perimeter of the circle. Now, today, we will devise a means or a method for measuring the circumference of the circle. Obviously, a circle is not like your rectangle or your triangle. It does not have straight sides that you can easily measure with a ruler. I mean, you cannot find a ruler that is circular to measure the length along the circumference. So that is where the problem may lie. But in mathematics, there is no problem that cannot be solved. So today, we will develop a method for calculating the circumference of the circle. Now, we can measure the circumference of circular shapes like your bucket, like your ball, like your tin or cylindrical shapes. We can measure the circumference of those shapes by simply tying a string around them like this. You know, tie a string around it and then straighten out the string and use a straight ruler to measure. Okay, I'll take that again. Tie a string around it. When it goes around, then straighten out the string and then measure the length using a straight ruler. That is one way of measuring the circumference of circular shapes. Another way of doing this is by rolling a circular shape like your tire. Just roll it around once along a path and measure the length of the path that is drawn. You roll it around just once until it comes around full circle like this. Okay, so you see, I'll take that again. So see, this line is on top. I'll roll it around once until it comes back on top, tracing the line as I go. Now it's back on top. So this line forms the circumference of the circle. So the question you want to ask is, Uncle Agbaje, is it every time we are to find the area of a circle that we will now cut it from our book and start rolling it along the floor? Well, no. So I can show you how we can use this method to find the circumference of a circle, and that is by relating the circumference of the circle to the diameter. Now look at the shape. This line, this straight line, of course, is the circumference. We got that by rolling this circle around once, and we got this straight line. But we can relate this straight line to the diameter of the circle to see how we can get the circumference. Okay, so let's see. So I've brought this circle right now and I've drawn the diameter. And so you can see that that diameter is not taking up the whole circumference. The circumference is the straight line now. The diameter is not taking up the whole circumference. So that means I can still accommodate another circle here. So I'll bring another circle. Now I have two circles. Their two diameters are now joined. But if you join the two diameters, it still doesn't take up the whole circumference. I think I can accommodate. Do you think we can accommodate another circle here? If I look at it, I think we can accommodate another circle. So I'll bring that in. And so now I have three diameters, end on end. Three diameters still does it equal the circumference? Well, I don't think it does, but there is a way we can check. Let's see. So this is the starting point and this is the ending point. It almost equals the circumference of the circle, but it is not equal. There is still a little left over here. But on the whole, we can approximate the circumference of a circle by simply knowing the diameter and multiplying by 3. 3 diameters is almost the same thing as the circumference of the circle. But you see this little part, we have to find out how much it is, because when we multiply the diameter by 3, it will give us an estimate of the circumference, but it's not going to be accurate. So we need to know how much this little part is. And I will tell you, that little part is actually 1/7 of a diameter. How can I prove this to you? I will divide the diameter into 7. 1, 2, 3, 4, 5, 6, 7. Okay, then I'll take this small part and show you that it is just occupying 1/7. So as you can see, it covers just 1/7. And so that means that the diameter or the circumference of a circle will be the same thing as 3 diameters and then a little extra. Again, the whole circumference of a circle is the same thing as the length of 3 diameters 1, 2, 3, and then a little extra, and that extra is 1/7 of a diameter. So the diameter is therefore 3 times the diameter and 1/7 extra, and that means that if I want to find the circumference rather is 3 times the diameter and 1/7 extra. So if I want to find the circumference, instead of drawing or taking a string, I can just know the diameter, which is a straight line, multiply it by 3, and then multiply it by 1/7 again, and I'll get the answer. So the circumference is 3/1/7 times the diameter. Keep that at the back of your mind. So for any circle, the circumference is 3/1/7 times of the diameter. Now, that 3/1/7 is the same throughout, and we call it the pi. We call it the pi, and that pi is spelled P-I, not P-I-E as in your meat pie, but P-I pi. And we usually use this symbol to represent it. So whenever you see this symbol, it means 3/1/7. This symbol pi, it means 3/1/7. Although there are other values for that pi, we also write it as 22/7, and that is just changing 3/1/7 to an improper number. Or sometimes we can write it as 3.14. It depends on the question. The person testing you might say, use your pi to be 22/7. The person might say, use 3.14 as your pi, as you will see. So now, keeping that at the back of our mind, the circumference of a circle is 3/1/7 times of the diameter. When we know this, we'll easily get the circumference of any circle. Let's check out this example. This says, find the length of the circumference of the circle. I do not need a string anymore to take around this circle. I already know the diameter. The diameter is 14 centimeters. So the circumference will be 3/1/7 times of that. So let's go. The circumference is 3/1/7 times of the diameter. And that is 3/1/7 times of 14, because 14 is the diameter, that line. So I'll just change this one to an improper fraction, and that will be 22/7, because 7 times 3 is 21. 21 plus 1 is 22 divided by 7. Then this 14 becomes 14/1. Now, let's simplify that further. 7 goes here 1, 7 goes here 2, then I have 22 times 2 centimeters. The circumference will now be 44 centimeters. It's as simple as that. When you know the diameter, just know that the circumference will be 3/1/7 times of that. Okay, so let's see another example. It says, find the circumference of this circle. In this case, what is the diameter, my friend? The diameter, of course, is 42 meters. And now that I know the diameter, I know the circumference will be 3 times of that, and then 1/7 extra. So the circumference is 3/1/7 of that, and remember that 3/1/7 is the same thing as pi. So when you open some of your textbooks and you see this pi, it means 3/1/7 times of the diameter. And so that is 3/1/7 times 42 meters, because in this case, the diameter is 42 meters. So writing our 3/1/7 as 22/7, changing it to improper fraction, then multiplying by 42/1. Let me simplify this. Okay, so how many 7 goes in 7? 7 goes in 7 one time. How many 7 goes in 42? 7 goes in 42? 6 times. Now I have to multiply 22 by 6. 2 times 6, 6 times 2 is 12. I regroup 1. 6 times 2 is 12 again. Then I add 1, I get 13. So that is 132 meters. Let's see if that is correct. So the circumference in this case is 132 meters, my friend. Now it's going to be your turn now. Of course, when you know the diameter, just multiply by the pi. And the pi is 3/1/7. You have to find the circumference of this circle. This should take you just 1 minute. Begin. Alrighty then, I believe that you found it very easy. Yes, of course, because this 28 is a number that can easily be divided with 7. So let's see how it's done. The circumference is pi times of the diameter, and that is 317 times of the diameter. In this case, the diameter is 28 centimeters. Now, 7 times 3 is 21, plus 1, that's 22. So we change our pi to 22 over 7, and then multiplying by 28, we see that we can simplify that further. 7 goes in 7 how many times? 1 time. 7 goes in 28 how many times? 4 times. Now 4 times 2 is 8. 4 times 2 again is 8. And so that means that the circumference of this particular circle will be 88 centimeters. Let's see if that's correct. Of course it is. And I believe that that is what you got, my friend. If that is what you get, or if that is what you got, then put your hand on your chest and say, I am special. Yeah, that you are, my friend. Now for your assignments, you will have one that is easy and one that is quite challenging, but I'm sure that you can tackle it. Copy this down. You have 1 minute. Alrighty then, we have come to the end of today's lesson in mathematics, but do not go away because you still have general studies coming up with Uncle Popo. Till I come your way in the next lesson, remain wonderful mathematicians. Bye bye now.
Hello, puppies. You are welcome to General Studies class. I am Uncle Popo. Uncle Popo is here.
I am also here.
Good. We are here together.
100% attention.
Excellent. And 100% attention is what you have promised to give me in today's lesson. Our subject for today is basic science and technology. And the topic we want to treat today is a very simple and interesting topic. In fact, most of you are very familiar with the topic. Some of you at times have been using the word to play. When your friend asks you, maybe at times they ask you, come and play, and you respond to tell them, I do not have energy. I do not have energy to play. So what does that mean? It means there is you don't have that power, you don't have that strength to play at the moment. So our topic for today is forms of energy. Say that, forms of energy. What are the learning objectives for today? By the end of the lesson, you should be able to define energy, and you should be able to state the categories and forms of energy. Now, let's define energy. Energy can be defined as the ability to do work. I know you are very familiar with that definition. Energy is the ability to do work. We can also say energy is the application of force to move an object. Application of force to move an object. Just like when I started that, I told you that you are very familiar with the word energy. You know, at times when your friend asks you to come and play, you say, I do not have energy. That means that ability to do that, to go and play or to exercise your power or strength, you do not have. So in one word, energy is the ability to do work. Now, talking about energy, we want to look at different forms of energy in today's lesson. Energy can be divided. Energy can be divided into 2 categories. Into how many categories? 2 categories. What are the categories? The first one is potential energy. Say that, potential energy. And the second category of energy is kinetic energy. Say that, kinetic energy. These are the 2 categories of energy that we have. Now moving on, let's look at what potential energy is. Potential energy is stored energy. Potential energy is what? Stored energy. While kinetic energy is the energy of motion. Kinetic energy is what? The energy of motion. Potential energy is stored energy. Kinetic energy is energy of motion. So like this now, this is just, this picture is talking about the potential and kinetic energy. Don't forget that potential energy is stored energy. Kinetic energy is energy of motion. This is stored energy here. That's why you can see this balloon blown in this form. Now kinetic energy, when you release the air from the balloon, what happens to this balloon? It moves away. That's energy of motion. Now, the law of conservation of energy states that energy can neither be created nor destroyed. Energy can be seen in a multitude of forms. That is talking about different forms of energy. Our focus is on energy, the different forms of energy. Energy never disappear, but only change form. And we have different ways to categorize the variety of energy that exists. That's talking about forms of energy. Today we are going to learn about 5 of the categories that energy can be sorted into. And I've erred in trying to put this first letter of each form of energy to form this word that I called melts. M-E-L-T-S-C. Melts. Melts. So we shall be looking at different forms of energy using the first letter. The first one that we have that letter M there, that is talking about mechanical energy. Say that. Mechanical energy, that is a form of energy. Another one is electrical energy. Say that. That's letter E, electrical energy. Next is light energy. Say that. Light energy. What letter do you think is the next? That's what? Letter T, and that is thermal energy. Say that. Good. What letter next? Letter S, and that is talking about sound energy. And the last one is letter what? Don't forget melt. That's letter C, and that is talking about chemical energy. These are the forms of energy we want to treat today. Mechanical energy, electrical energy, light energy, thermal energy, sound energy, and chemical energy. Talking about mechanical energy. Mechanical energy is the energy acquired by the object upon which work is done. Mechanical energy is the energy acquired by the object upon which work is done. Mechanical energy is the energy that is possessed by an object due to its motion or due to its position. Mechanical energy can be either, we have talked about, can either be kinetic energy, that's energy of motion, or potential energy, that's stored energy. So that is mechanical energy. Moving on to the next one, that is electrical energy. That's another form of energy. Electrical energy is a form of energy resulting from the flow of electrical charge. Electrical energy is a form of energy resulting from the flow of electric charge, from the flow of electric charge. In electrical energy, the force is electrical attraction or repulsion. What are we saying here? Between charged particles. Just like we have, if we have two objects or particles that can attract, that can connect, that's talking about attraction. And at times, we have some objects or materials that will not connect to that electrical particles. In one word, electrical energy is a form of energy resulting from the flow of electric charge. Next one, another form of energy is light energy. Light energy is a kind of kinetic energy with the ability to make types of light visible to human eyes. Light energy is a kind of what? Kinetic energy with the ability to make types of light visible to human eyes. So that's talking about light energy. And light is defined as a form of electromagnetic radiation. I know some of you will be like, wow, what is this? So as you are progressing, you will be getting familiar with some of these terms or terminology. Electromagnetic radiation emitted by hot objects like your lasers, your bulbs, and the sun. So light contains photons, which are minute packets of energy. And when we talk about light, light travels in waves. Light travels in what? In waves, and is the only form of energy visible to the human eye. Next one is thermal energy. Say that. When we say thermal energy, we are referring to heat energy. Thermal energy, we are referring to what? Heat energy. Thermal energy is the energy that comes from the temperature of the heated substance. Thermal energy is the energy that comes from the temperature of the what? Heated substance. That's thermal energy, which we also call heat energy. So this is just example of thermal energy or heat energy. And next form of energy is what? Sound energy. And when we talk about sound energy, we are saying that sound energy is produced when an object vibrates. When an object vibrates, the sound vibrations cause waves of pressure that travel through a medium such as air, water, wood, or metal. So that is talking about sound energy, and we could hear that sound when an object vibrates, or we say sound energy is produced when an object vibrates. So moving on to the last one. And the last one was the last letter when talking about melts. You know, the different forms of energy I've helped in using it to form, using the first letter of each of them to form one word called melts. M-E-L-T-S. And this is the last letter, C, that is chemical energy. Talking about chemical energy, chemical energy is the potential of a chemical substance to undergo a chemical reaction to transform into other substances. I'll just give you an example to make you understand what I'm talking about. For example, talking about chemical energy, we have something like coal. Coal now could undergo a chemical reaction to transform into another thing, just like wood. When it undergoes chemical reaction, it's your wood now. When you look at this picture, now this is wood. Now when it's burnt, it changes to another form. It could turn to your coal. That's talking about, we have different examples of chemical energy, but this is just an example. So in today's lesson, we have talked about what energy is and different forms of energy. You were told that energy can be defined as the ability to do work or application of force to move an object. Different forms of energy, don't forget melts, M-E-L-T-S-E, mechanical energy, electrical energy, light energy, thermal energy known as heat energy, sound energy, and chemical energy. It's time for evaluation. I have two questions. Question number 1, what is energy? Question number 2, list 5 forms of energy. You have just 30 seconds to attempt this. Your time starts now. Eyes on me. Uncle Popo is here. Good. So let's mark together. What is energy? Energy can be defined as the ability to do work or application of force to move an object. List 5 forms of energy. We have mechanical energy, electrical energy, light energy, thermal energy known as heat energy, sound energy, chemical energy. So just 5 out of the different forms of energy you were taught today. So mark accordingly and rate yourself. We have come to the end of today's lesson. Until next time, next lesson, Uncle Popo says, keep on studying. Bye.
My wonderful pupils, we have come to the end of another exciting episode on the Classroom in Your Home.
An exciting one indeed it has been for us. We have enjoyed ourselves learning with you today, and we hope that you have had fun learning from us as well, and you were able to pick up 1 or 2 things in your classes in mathematics, English studies, and of course, general studies. Now, practice is the mother of perfection, and you know that we have our online assessments for you to try your hands on and see how well you have learned today's lessons. You can find all these online assessments using the link bit.ly/LASUBEB-TEST. Link again is bit.ly/LASUBEB-TEST. There you'll find exercises on lessons that we have taught from the beginning of this program till date.
Taking the online assessment on bit.ly/LASUBEB-TEST is based on if you have access to either your daddy's, your mommy's, your uncle's, or your auntie's Android or smartphones.
Yeah.
If not, you don't have a problem. Just send your comments, your questions, and your assignments to 081 50 86 5663. Please send your assignments there, and when you're sending your assignment, make sure you indicate your name,
Indicate your school,
Your class.
and your local government education authority. And I've always told you, do not call that line. SMS and WhatsApp messages only.
All the exciting lessons we had today and the previous ones are on Lagos UBEB YouTube channel for you to watch at your own preferred time. Subscribe to Lagos UBEB YouTube channel to get notification when new videos are uploaded. The Classroom in Your Home could be watched live on Facebook through the page showing on the screen.
Until our next lesson, when we shall meet again on the Classroom in Your Home, make sure you do your homework and submit promptly.
Wash your hands regularly.
keep studying hard, but above all,
Stay safe.
because at LASUBEB,
We leave no child behind.